Hello, welcome to this second tutorial to do with binary numbers. We're going to make a converter so that we can, let's go on my JavaScript binary converter here. We want to be able to put in a decimal number, like our favorite 42, convert it, and then get our binary code, our binary string. So 42 in binary, if you didn't know, is 010101, a nice pattern of ones and zeros. Now, if you don't know what binary numbers are, or you haven't seen the previous video, it would be a good idea to see that, and then you will know exactly what we're doing with this code. In the previous video, we put together this very short bit of Python code here. So what we did was convert from a binary number into a decimal number. I could have just used. I just realised I could have just used run this program to show you how to do that. So let's put in 111 in this list. So there are three like digits in our binary list here. And so what this program will do is spit out the decimal, which should be 7. Yes, 111 is 7. Again, if you're unsure about how binary numbers work, have a look at the first video where I explain that in detail. Okay, so something that I didn't do actually here was implement it so that it's just started to rain really hard. Anyway, how exciting. So what we didn't implement is how the user might input their own binary string and then we convert that. Sorry, they're binary, and then we convert that into a decimal here. So let's just see if I can do that. Let's see if we can do that. As you can probably tell, I haven't kind of planned this, so which is not a good idea. If you're doing a kind of tutorial, make sure you can do something and do it a few times, and then you'll be more clear when you explain it to someone else. Anyway, sometimes it's fun just to try and do something. So what's happening in our program? We're just saying the decimal equals, and then we run our function. We call our function convertMe, and then we've got our binary list already kind of like hard coded here. So what might be good is that we say actually bin list will equal an input. So that's the function we can use in Python, and then you can write like a little message like enter binary code, and let's put a little triangle. I forgot what those were called. What are they called? Oh, it's on the tip of my tongue. Begins with an E, doesn't it? It's like a echelon? No. Oh. I'll remember one day. Okay. So, right. Let's just see if that works. So what we're saying here is store whatever the user inputs. So after they press the return key, enter key, after they put something in, that whatever they put in will be stored in bin list. And then will our function just work on that? Will it convert the binary list? I'm guessing not. Let's just see what happens. Right, I need to stretch out the shell. So enter binary code, and let's try 111. We know that should be 7. Press enter, and there we go. We've got a nice bug, as we kind of expected. So line 19, in convertMe reverse. A string object has no attribute reverse. So basically, what's happening here is a type error. In our convertMe function, one of the first things we do is get hold of the binary or the list that was passed into this function, and we reverse it using this list function. Now the problem is, when you enter something in Python, that's going to be stored as a string, and that's what it was saying down here. Attribute error. str object has no attribute. So it's a string, and it's saying we can't use that as a list. Right. So the question is here, I guess, I sound really confident, still don't really know what I'm doing, but here, can we convert the string into a list? That's the question, and I think we can. I think a a string usually in programming languages is a list or is a kind of array. So can we just iterate over that? So we could say, let's say p equals, or rather n equals 0. So while n is less than the length of this object. Or I wonder if we can just do that first of all. Let's just see if we can print out the length of BL, and we'll just make sure that is a string because the print function works. Or maybe, I'll just make it into a string. Now I'm changing my mind again. Maybe if we're not concatenating, the print function will understand in Python. You just want to print out that number. And then, I guess, let's just comment out the rest of this. I feel a sneeze is coming on, so maybe mute your microphone. Sorry, your speaker, your headphones, whatever. I'm about to sneeze. I can feel it coming. Oh, excuse me. Twice. And I'm not going to edit that out because I'm lazy. Right. So we've sneezed, and we've commented out that function. So now if I play it, hopefully it's just going to print out the length of this string, which should be 1. Actually, if I just put in 111, there's 3 digits, so the string length should be 3. Fantastic. It has printed out 3. Okay. What does that mean? That means that this parameter, this string that we're passing in to convert me, is like a list, but it must be some kind of string array thing. So what we should be able to do is iterate over. So let's type out again. So n equals that. I should just do like a for loop, but I've forgotten how to do it in Python, so I'm just using while loops all the time. Next video on Python, that's what I'll try and learn. So while n is less than the length of our string, that's what I was just testing there. So we know that works. What we basically want to do is say, let's have a new binary list kind of set up. And what we're going to just do is say new BL position n. So it's just going to copy through each of the letters, and we just want to convert it into an integer. And let's just put in the string variable and then at position n. So it's just copying whatever character we've got in the string array at the position from 0 to the length of the whole string, converting it into an integer, so a 1 or a 0, a whole number, and then placing it in the right place in our list. I'm just thinking now, I think we can just plop in the... No, I'm thinking maybe we can't just plop in those values because the list doesn't actually have the containers ready. I don't think lists work like that. So what we can just do is use append, which means add to the end of this list a value. So we're just gonna, it's a very similar thing to what I just tried to do, but there I'm just saying add to the end of this list. And at the moment it's got nothing in, so just in the first position, or index 0, add in the first character that we find. Then when we loop around again, n needs to be incremented, doesn't it? So n plus equals 1. So n will go up, find the next character, plop it onto the end of this. Brilliant. Then we can reverse, yeah, we can reverse our binary number code. I'm just thinking, oh, right. I just remembered I commented all of that out. Okay, so then, sorry, the rest of our function should work as we designed it before. Okay, let's let's give that a go. I'm just getting confused in my head about whether I still need to reverse it. Because if we've got, yeah, we do need to reverse it. I just realised how our function works. Okay, and notice I'm not explaining why, because I really haven't got it very clear, but I think I've got that. Okay, 111 should spit out 7. Something's gone wrong. Let's have a look. Dec x equals convert me. NLB is not defined. That looks just like a typo. Well done if you spotted that. Yep, NLB. It should be NBL. There we go. Oh, and then look. I tried to reverse BL. Okay. You know what? This is really quite bad because if I wanted to revert to how this program was working previously, then I've got to change all of these back. So this is not good practice, I guess. Although, one piece of advice maybe for programming is, you know, just don't try to generalize too early. Just try and do the one thing that you're trying to do, and then later on generalize. But often you try to like generalize things at the beginning. Okay, so let's just read through what's going on here. So I call convert me, and I've got a string here, like a string array kind of thing. And then I'm saying the decimal number equals 0 at the moment. We don't know what decimal number this binary number or string is going to equal at the moment. Then we create ourselves a new binary list object, which is completely empty. Then we loop over the string, and for each character along the string's length, and we can put in any length we like, we then append or add to the new binary list that value, making sure we convert it into an integer, each value, so just a 1 or a 0 there. So we've looped over all of them. Then we're going to reverse that so that we can loop over the binary number from right to left, and we find all of the decimal number values by 2 to the power of what position it's in. This is all covered in the previous video. Then we return the decimal number, so then we finish the convert me, and so we're down here. So bin list equals the input, and yeah, decimal number will equal that string being converted. That's the function we've just gone through, and then it spits and then it prints it out. Okay. So I'm going to say with confidence, clear the console. Definitely no bugs. This is going to work first time. Although this is like the 4th time. Okay, 111 should be 7. We did it. We did it. Now, what would be really nice is if you had like a little loop going down here, so that you could. My chihuahua getting excited. I might go and open the door for her in a moment. Yeah, have a little loop going, and then your user could just keep adding in binary numbers to their convenience. So, what binary code should we put in? Let's put in 101, 101. Enter 5. It's working. Brilliant. Okay, so the main thing about this video, the point of this video was we don't want to convert from binary to a decimal number. We want to go from decimal to binary. Now, if I remember at the end of this video, if someone could put in the comments, this would be a nice like timestamp for those people who just came to this video to find out this bit, so they wouldn't have to go through the previous stuff. Okay, so this little area. will be useful to work out some stuff. So, how on earth are we going to do this? So we're going to get a number like this, or like 101, and we know that that equals 5 in decimal. How do we go from 5 being 101? How do you do that in the reverse process? Well, the way I work this out, and I've worked like 2 algorithms to do it, is, well, here I kind of want you to pause the video and maybe go away and see if you can work it out yourself, without looking on the internet, obviously, or through any books, but just see if you can think of a way, and then see if it's the same as mine. And if you're happy, unpause the video, and then I'm going to tell you now. Okay, so spoiler alert, I'm now going to tell you how to do this. So let's have a look at binary numbers, and let's take 3 digits, and we're going to count up from 1 up to, I don't know, 5 or 6 or something like that, or 7. 7 would be good. So we want to go from 0 to 7. So we know 3 ones from right to left equals 7, because we've got 1 plus 2 plus 4. So 4 plus 2, 6, plus another 1 is 7. Okay, 0, 0, 0 is obviously 0. So what's the next one? 0, 0, 1, or 1, 0, 0. And then to get to 2, we go 0, 1, 0. And then 3 would be the 0, 2 plus 1. Does that make sense? Then we want 4. That's quite easy. 1, 0, 0. 5 is going to be 4 plus 2, isn't it? 0. Where are we up to? 5, I think now? Sorry, 6. And that looks right. Sorry, where are we? That's 4. 5 is 4 plus 1. Then 6 is going to be 4 plus 2. Right, let's just see if that makes sense. So that's 0, that's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7. Very obviously, if this is making no sense, the first video is maybe what you need to watch. Okay, where I explain the very basics of binary numbers. So there we go. We've got 0 to 7. And if we need another, if we wanted to go high, if we wanted to go to 8, there's no way we can do it with 3 numbers. Like 111 is maximum, isn't it? So to get to 8 would be 1, 1, 0, 0, 0. No, would it? Yeah, that would be 8. Okay, and then 9 would be that, and so on. Okay, so the reason why I've written this out like this is because when I did that, I saw a pattern, and I wonder if this is what you discovered if you tried to work it out yourself, which is definitely the most interesting way. So again, I'm going to give you an opportunity here. If you hit a brick wall and you didn't know how to work it out, I think the key is looking at this pattern here. See if you can see a pattern. And as soon as you've got a pattern, you can use that in code because it's predictable. It's mathematical. There's something where an expectation and therefore a rule exists. Okay, look at the first, so unpause, so spoiler alert, I'm going to carry on now. So look at the first digit. It goes 0, 1, 0, 1, 0, 1, 0, 1. So it alternates. The next digit, or position 1, we go 0, 0, 1, 1, 0, 0, 1, 1. Can you predict what's going to happen to the next one? So the position 2, 0, 0, 0, so 4 zeros, maybe I said 3 there, 0, 0, 0, 0, and then it goes 1, 1, 1, 1, so we get 4. So it alternates by 1, then it alternates by 2, then it alternates by 4. So it's basically alternating by the same value of that position. Remember, position 0 is worth 1, position 2 is worth 2. I got confused. Position 0 is worth 1, position 1 is worth 2, position 2 is worth 4. You can see how that's confusing. So basically, we can ask the question when we're trying to decode from a decimal into binary. We can say we want to answer this question: do we need to switch this digit on? Does it need to be a 1? We can presume, we can just kind of like load up and say, we'll just have a load of zeros, and then we'll see if we need to switch you on. And the way we can do that is, perhaps if we look at the position second, position 2, so 0, 1, 2, we can see it most easily here. If we divide our required value by the phase kind of number, so the phase of this would be 4, the phase of the first position would be 2, the phase of the 0th position would be 1. So if we divide by that phase of the position that we're at, and then ask if the result that we get from dividing the value by the phase that we're at, if that's even, so 0 point something or 2 point something, then we don't switch on that digit because it'll still be in 0. For example, if we try to go to any of these values, 0, 1, 2, or 3, if we did, let's say, the largest number here, 3, so that's the value we're after, the decimal value we're after, divided by, let's see, we're looking at this second position, so where this 0 is, we say divide by the second position to the power of 2, sorry, 2 to the second position, so that's going to be 4. What's that going to equal? It's going to be 0 point something. Now, the point something we don't need to worry about. We just want that first digit. And we're going to then say, is that even? If it is even, then don't switch it on. If it's odd, then switch on that digit. That's basically what's going to happen. Because notice, as soon as we go to, let's say, any of these numbers, 4, 5, 6, or 7, if we go 4 divided by 4, so we know that's the position's value, the phase number of the second position digit, that's going to equal 1. It's going to be exactly 1. Is that even? No. So we're going to switch on. Whoa, my light just flashed and it really scared me. Why did that scare me so much? What's going on? Oh, I wonder if there's some lightning. I don't know. You were here. I'm glad you're here with me. Right, mysterious. Okay, so I feel like I'm kind of like rambling this bit, but am I making it clear? Am I making it clear? I wonder. Let's just have a look at then this first digit, or the 0th position. Let's do the same thing. So let's say we're after the value 3. So when we were looking at this digit, at the second position, we found that when we divided it, we got 0 point something. So 0 is an even number, funnily enough. If you think about it, I'll just explain that quickly. Even and odd numbers in the number line alternate. So 2 is even, 3 is odd. 4 is even, 5 is odd. 6 is even, 7 is odd. And so have a look at where 0 is on the number line. It's next to an odd number, i.e. 1. So it must be even. And then minus 1, that's odd again, etc., etc. Anyway, so 3 divided by 4, we found that's 0 point something, so that's an even number. So we don't switch that digit on. Now let's have a look at the first position. So that will be 3, that's the decimal value we're after, divided by 2 to the power we're at the first position, 1, which is just 2. 3 divided by 2 is 1.5. And again, it doesn't matter about the point, so I'll just leave it as 1. 1. Is that even? No. So we switch it on. And look, it is switched on. So it's working. Let's do this one. So the 0th position. So 3 is the decimal number we're trying to find out. And again, it's 2 to the power of whatever position we're at. We're at the 0th position. So 2 to the 0th, that equals 1. So 3 divided by 1 equals 3. Is that even? No. 3, newsflash, is not an even number. It's an odd number. So we switch that digit on, and indeed it switched on. So we found our little algorithm here. Okay, so the first step, I think, is easier to do, but I've just forgotten. I forgot to get this clear in my head earlier on today to work this out. So here we go. Let's work this out live. So the first thing I kind of said, but very briefly, was we're going to loop over just a number of digits in our binary code that we're creating, and then we've just solved how to answer the question, do we switch this one on? Do we switch this one on? Do we switch on the next one? Do we switch on the next one? But we haven't worked out how many digits will we actually need. How many digits will we actually need? So I did work out a formula to work this out, and I think it involves a logarithm. Because basically we're saying we went from a binary digit before, and we basically said to do that, we're just going to add up, where's our function? Yeah, we're just going to add up 2 to the power of whatever position that digit is in. So basically we're wanting to go in the reverse and kind of see, well, what is this length going to be? Now, the reverse of an exponential in mathematics is going to be a logarithm. A logarithm is the opposite of raising a number to a power. Let's see if I can give an example of this, bearing in mind I'm not a mathematician or very good at math. So let's do 2 to the power of 4. What does that equal? Well, that's going to be 2 times 2 times 2 times 4 times. Okay, so that's going to be 2 times 2, which equals 4, times 2, which equals 8, times 2, which equals 16. Wonderful. Okay, so that's exponentiation. God, I almost feel clever here. Exponentiation. There we go. If I've spelled that wrong, don't tell me. Just let me pretend that I can spell. There we go. So exponentiation. Now, a logarithm. I don't think I've ever written that. A logarithm is going to be the opposite of this process. We're going to say log base 2, and I need to like a downward arrow. Anyway, I'll just have to put log base 2 to get to 16 equals what power? What power? So it's the opposite. So here's our base. Our base number is the number that's being multiplied to itself. And the power number is how many times you do that. So a log is asking for what base you've got, how many times to multiply that base by itself to get to this number. So log base 2 of 16 equals 4, because it's the opposite. So if you think about it, we can ask for a number, for any decimal number, we can say, how many positions are you going to need in order for us to get to this decimal number? As I say that, all the confidence in my voice kind of drains out. But let's test this out. So if we if we had 16, would we need 4 numbers? I think we would. Let's have a look. 8 plus 4 is 12. Yep, 12. Plus 2, 13, 14. Plus 1 more, 15. So we can't get to it with 4 numbers. So do we do this? This is sounding more familiar now. It's kind of jogging my memory. Do we basically ask log 2 of our decimal number, whatever the decimal number is, minus 1? I think that's it. I think that's the formula that we need. Let's just experiment again. Let's experiment with a number that we know. So 111 equals 7. So what we want to ask, if someone has asked for 7 in binary, let's put that into our little formula down here. So we're going to do, what's log 2 of 7 minus 1? And we want that to equal 3 point whatever, but as long as we get 3, that gives us the answer to our question. We just want 3 digits. Okay. In the same way, 0, 0, 1. Oh yeah, we just need 1 digit. What's 1, 0, 0? So that's 4, isn't it? So if we did log to the base 2 of 4 minus 1, we should also get 3. And again, we might get point blah blah blah, but we can ignore that. So we can now go and test this out. Let's use Google and put in log 2 of 7 and log 2 of 4. I'll just take off the minus 1 for the moment. So as long as we get 4 point blah blah blah, or 4 point blah 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 here, we know it's working because we're going to minus another one. So let's just go and do that. Log 2 of 7 and log 2 of 4. So log 2 7. Log 2 of 7 is 2.8. So we did not want that. We did not want that. Log 2 of 4 is 2. So we actually wanted to add something on there. Let's go back here. What's going on? So that seems to be wrong. We want to do log 2 dec plus 1. And so we didn't get 4, we got 2. Oh, so maybe my doing the logarithm of 16, maybe that was wrong. Okay, let's do log 16. Log 2, 16. No, it does equal 4. I can't believe I just doubted myself that log base 2 of 16 did not equal 4. Okay. So there's a problem. It needs 5, so it needs... Oh, wait a minute. Are you just sitting there thinking, I've got the answer, but I just made a weird mistake? Yeah. So, so, in fact... Oh my god, this was just a stupid logical error as I was trying to explain things. I just put a minus 1 instead of a plus 1 to begin with. So, yeah, to get to 16, we need 5. So it needs to be 4 plus 1. Okay, and that's what I was doing down here. So yeah, so when we do log 2 of 7, we get 2 point something, and of course we need 3, and log base 2 of 4, we need, okay. I'll leave all that nonsense in. Okay, so to conclude, so we've got kind of our pseudocode method here. Basically, we're going to first find out how many digits in our binary code are we going to need, and then we can build a loop. We can say loop around that many digits. So if we're given 7, we're going to say, okay, we need 3 digits, and we're going to loop around 3 times. We're going to build a little binary list out of 3 digits, and then for each digit, we're just going to ask whatever number they've given us, like the decimal number 3 or 140, divide it by whatever value we would be at for that position, and is the resulting number, and we could just have the first number. To get to the first number, by the way, in most programming languages and Python, if we had like 12 point blah 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 blah, if we just want to get 12, we can just say floor that number, and that will give us the number that's should be there. Sorry. Like that. Okay, so it just chops off all of that stuff. It just floors it to the lowest whole number that we've got here. Okay, so that floor function will be helpful. Okay, so yeah, so we just loop over each of the empty digits. If this little question is even, leave the digit off. If we get an odd number, then we can switch it on, and that will then fit this pattern. It's where did my pattern go? It's then going to fit this pattern, which will hold true all the way to infinity. So whatever number they put in, whatever decimal number they put in, the pattern fits. Okay, so let's go and write that. So let's write it above the convert me. So we want a new function, and we'll call it make binary, please. Polite. Make binary, please. And then we're going to get, let's be brave and just get, we'll call that BS for binary string. Let's just imagine that we're going to allow the user to input it, because we did that earlier on, so we can maybe do something similar. So first we want to say new, let's call it decimal, ND equals, and let's have it as an int, or make it into an integer, which I think I can just do by doing that. Hopefully that will be an integer number now. Okay, so the first thing we want to do, now is decide how many digits do we need. How many digits do we need? So we'll call that digits equals, what was our logarithm thing? It's going to be math log. Hopefully that's how we get logs. And we usually put in, do you put in the base first and then put in the number? So our number is going to be the new decimal number. So that's going to be that integer. Okay. So we've got the number of digits. And now we can iterate or cycle or loop over this number over the required digits, and decide for each digit whether to switch on. Okay, so let's say I equals 0 while I is less than digits. There we go. increment I by 1 each time we go around. So what was our first question was, let's just go back to my notes up here. It wasn't the logarithm stuff. Oh, log plus 1. Well done if you saw me miss that out. Plus 1. There we go. Oh, and also we want digits just to be a whole number. So let's do math dot floor digits. Digits equals that. Okay. Now I'm using this math library. I think that's how I write it. So I've got to include that up here. Include math. Is that right? Let's just try and play something here. It's probably lowercase. Show my inexperience. No. Oh, is it import? I'm trying to write in C++ or something here. Import math. Okay, it's hopefully imported math there, and that means maybe I'm thinking in JavaScript. Maybe I need those to be lowercase. Okay, so what have we got? We've decided how many digits we need. Now we're iterating over them, and then I was just reminding myself of what to do. Oh yeah, basically we're saying the decimal number divided by the value of the position. Is that even or odd? Okay. So we're saying the number that we're passing in is now called ND, new decimal, because we've made it into an integer. Okay, so new decimal divided by, and now we want to be at 2 to the power of I. So we start at position 0 and we just go along the digits to how many digits we need. And what are we saying? We're saying, is that result odd or even? And it wants to be floored first, math.floor. So with that function just chops off all the decimal points, all of that stuff. So we are saying if this number is even or odd. So a quick way of doing that is just to use the modulus or modulo operator, which is not percent here. That means divide this by 2, and what the modulo operator returns you is the remainder. So 3 divided by 2, 3 modulo 2 is 5. No, it's 3 modulo 2 is 1. The remainder is 1. Sorry, I was doing the decimal number. Because 2 goes into 3 once, and then you can't fit another 2 into the 3. What have you got left over? You've got 1 left over. So that's what modulo does. Anyway, so if you divide any number by 2, if it's even, you won't get any remainder. So that's a way of checking if a number is even or not. So if our number modulo 2 is 0, in other words, if there's no remainder, it must be even. Therefore, we'll say, oh yeah, we need a binary number to make. So we want, at the start here to say our binary baby equals nothing at the moment. So we're going to append to that binary baby list, binary baby append 0. There we go. Then we're going to go to the next position as I increments. Okay, lovely. So, we've got to say else binary baby append a 1. So if we do have a remainder, meaning we've got an odd number, then we want to switch on that digit as explained earlier on using our phase pattern that we discovered. Hopefully you discovered something. Again, if you discovered a better algorithm or a different algorithm, I don't know how to judge better algorithms, I don't know what that means, but an interesting algorithm, you can put that in. Okay, so we've got that. So one thing that I just thought about is the fact that we are appending over here. So we're appending to the end of our list each time our digit, which is going to be the wrong way round. Because, yeah, it's just going to be the wrong way around. So we want to reverse our binary list, our binary baby. So we'll say binary adult equals binary baby reverse. No, let's just, I can just do this. Binary baby dot reverse, that just reverses the actual object. I'm thinking some other programming languages, if you do like a reverse thing on an array, it will return like a copy of that array. I don't know. Okay, so here it's actually Python actually works on that array. It doesn't create a new list or anything as far as I know. Okay, so we reverse binary baby. I think now we're done. We can just return binary baby. We've done. Oh, okay. I don't think this is going to work because we've done a lot of coding there without testing stuff. So, where's our program flow? So first we enter a binary code and we get a decimal number. Let's do the opposite. So we're going to say new dec equals input enter decimal number, and then we're going to say bin x equals what do we call it? What do we call our conversion function here? There's something different. Make binary, please. Oh yeah, make, this is going to be a string. Make binary, please. And we're going to pass in the new dec string. Let's just have a look. I did convert that string, didn't I? Yeah. So that string is going to be converted into an integer number. Okay, fine. And then we just want to print out print binary equals plus, and we can only concatenate strings, and that's going to be bin x. There. Okay. Let's go. Oh no. Flaw. Invalid syntax. Modulo 2. Math flaw. modulo 2. Oh, I put equals equals. Do I just need to do equals? No. It might be this line break that I used. Might be my... I have used the right modulo there. I'm just thinking, have I got enough brackets and things like that? Let's try running again. Okay, so a different error here. Indent error, expected I, indented block. Where is that? 72. Okay. Run again. Oh, it's running. Okay. So I had some classic Python errors there, like indentation. Enter a binary code. So let's do 8. So that's going to be 1, 0, 0, 0. Or reading it in binary, 0, 0, 0, 1. Enter. Decimal equals 8. Okay, that was already working from the beginning of this video. Enter a decimal number. Let's put in 8, because then we should get out 1000 or 1000 or 00. Okay, so we got something out, but something's gone terribly wrong. We have got a binary list, but it's a 0. Okay. So let's go and debug. What on earth has gone wrong? Let's just go down to the bottom, the uncomplicated stuff first, and let's make sure this is okay. Right, new decimal number equals input, enter decimal number. New deck, make binary please, new deck. Bin x equals that, bin x, string. Okay. So the question is, why on earth is it just returning a 0? So we're reversing it. Let's just comment out the reversal and see if that's the problem. No reason why it should be. Enter decimal number 8. We're getting 0. Okay, so that hasn't solved the problem, but we know that that isn't the problem. So number of digits. So maybe we're only getting a 0 here. Did we plus 1? Yeah, we do. Math, log. Right, this is one thing I didn't know about. Have I got these numbers the right way around? Because it might be log of this number base 2. I may have got the parameters the wrong way around. Let's just see if that works, and then maybe we'll just go and check in the online documentation afterwards. Enter binary code. Let's do. I'll go for 9. 1, 0, 0, 1. That is 9. Okay. If I put in the decimal number, I won't put 9 actually because it's palindrome. We won't know if it's the right way around. But we'll put 8 in. 1, 0, 0. Guys, it works. Well done. We did it. Our algorithm worked. Oh, and I really will be thrilled if you have a different algorithm and that works in an interesting way. But there we go. I should probably test more of this. Let's have a look. What is 120? No, that's the right. Let's just put in that binary number. Right. What is 123 in binary? Is 1111 Okay. Let's just see if I've got that right. I can check on my other one. Although, this one works. This JavaScript one works by a different method. So that looks very similar. So we're probably okay. Let's just ask Google 123 in binary. 11111011. Brilliant. Okay, so it's working. So we did it in those 2 steps. Let me just show you again. make binary, please. So we take our string, we convert it into an integer, then we build a list, an empty list. We find out how many digits we need by taking the logarithm base 2 of the decimal number, and then we add 1 to that number. Then we just get the floored version of it to give us a nice whole number so that we can iterate through here with no problems. So we go through the number of digits we need and we just ask if the decimal number we want divided by like the positional value of that digit is even, then add an even, then add a 0, don't switch on that digit. Otherwise, if it's odd, switch that digit on, and then we reverse the binary number at the end. And we return binary baby. That's how we do it. Okay, so I was just going to check, say math Python log. Looks like I've been here before. I've been purpled out. So here's all the mathematical functions, if you're interested. There we go, log. Yes, so the base is the second number, so I put it the other way around before, so that's the problem. Okay, right. I can't wait to find out how long this video is. If I've kept it under an hour, that'd be brilliant. Thank you very much for watching. I hope some of that was useful, and if you have any questions, put them down in the comments and I'll try and answer those. Okay, have a lovely rest of your evening or morning or whatever else. Goodbye.